Hello, good afternoon, everyone. I am Nishu Sharma, lecturer in Mechanical Engineering Production Department in IIMT College of Polytechnic. Today, we will discuss the terminology of gears. So, firstly, we will discuss this topic, that is the terminology of gear. Firstly, we will discuss the what is the gear. So, basically, gear is used for a power transmission device, and there are a lot of things to transmit the power from the one shaft to the another shaft, like as a belt and pulley, chain and gear. Gear is also uh, one thing that transmit the power from one shaft to another, that is also called a power transmission device. So gear is basically a friction wheel with teeth cut on it and known as tooth wheel or gear. So in the gear there is a teeth is cut on the periphery of the gear. So to the cutting of the teeth on its periphery, so it is also called as a toothed gearing or toothed wheel, because this is a wheel in which a teeth is mounted on its periphery, and there are the motion and power is transmitted by the gear. And in this diagram we see that this is a gear in which two gears are mashing, and the first gear is the driver gear and another one gear is the follower. And driver is the that gear which follows to another gear, that is called the follower, or also called the driven gear. Okay, they and okay. So now we will discuss the advantages of gear drive. So basically, gear is used for a power transmission. It will have a lot of advantages, and the advantages of the gear drive is that it transmits the exact velocity ratio. So firstly, is the what is the velocity ratio? Velocity ratio is nothing. It is just a uh, ratio of the speed of the driving gear to the driven gear. And basically we can say that to transmit the power of the gear, so it transmit the exact velocity ratio. It may use to transmit large power. It has high efficiency. It has reliable service. It has compact layout. Basically, these are the advantages of the gear drive. And now is there is the disadvantages of gear drive also. So basically, there are the two disadvantages of the gear drive. First disadvantages of gear drive is the gears are manufactured by a special tool and equipment, because there is a skilled worker also required to produce, or we can say that to manufacture the gear, and a special tool requirement is also, so we can say that it is a costly equipment. Okay, so the first disadvantage of the gear drive is that the gears are manufactured by special tool and equipment. And second advantage is the error in cutting teeth may cause vibration and noise during operation. We have seen in a lot of our vehicles that when there is not proper meshing of the gear, so there is a lot of vibration and lot of noise in the operation of gear. Now we will discuss the classification of toothed wheel, or we can say that the classification of the gear, because gear is also known as a toothed wheel. So there are the classification of the toothed wheel. There are basically four types of classification of toothed wheel. First one is the according to the position of the axis of shaft, and next is the position of the axis of the shaft. Next is the according to the peripheral velocity of the gears. Next is the according to the type of gearing, and last one is the according to the position of teeth on the gear surface. Now we will discuss it one by one. Firstly, we will discuss the classification according to the position of the axis of the shaft. So there are basically three types of gear according to the position of axis of shaft. Basically, first one is the parallel gear, another one is the intersecting, and the last one is the non-intersecting and non-parallel gears. So firstly, we see that the first gear, the parallel gear. The parallel gear is is shown in this diagram. This is the parallel gear, and the parallel gear, a collinear shaft, is called the spur gear. Okay, and the arrangement is known as the spur gear. These gear have a teeth parallel to the axis of the wheel, which is shown in the diagram. In this diagram we see that there are two gear, driver and follower, and the axis of the driver is shown by the dotted line, and the position of the teeth is the parallel to the driver axis and the follower axis, so it is called the parallel gear. And the example of the parallel gear is the spur gear. Next gear is the intersecting gear. So intersecting gear is the non-parallel or intersecting gear, and this is called the intersecting gear, and in which the axis or the position of the teeth is not parallel to the axis of the gear. And the example of this is called the bevel gear. Spiral gear is the example of that gearing. And these gear are called bevel gear, and the arrangement of the gear is the bevel gearing. The bevel gear is like as a spur gear, and also have their teeth is inclined to the face of the bevel. Okay, and in this they are also known as the helical bevel gear also. And next classification according to the position of the axis of the wheel is called the non-intersecting and non-parallel gear. And the example of this is the spiral gear, and in which the non-coplanar shaft are connected by the gear, and in which these gear are called skew bevel gear, or we can say the spiral gear, and the arrangement is called the screw bevel gearing, or we can say that spiral gearing. And the type of the gearing also have a line contact, which is shown in the diagram, and the rotation of which about the axis, the two shape is called hypocycloid. Next classification of the gear is according to the peripheral velocity of the gear. The gears, according to the peripheral velocity of the gear, may be classified as basically there are three types of a gear. The first one is the low velocity gear, next is the medium velocity, and last one is the high velocity. It is according to the velocity of the gear. The first one is the low velocity. It means the gear having velocity less than 3 meters per second are termed as low velocity gear, and the gear having a velocity between 3 and 15 meter per second are known as medium velocity gear. And last one is the high velocity. It means greater than 15 meter per second, that this is called the high speed gear. Okay. Now next is the according to the type of gearing. So basically in this type of classification, the gear are of three types: external gearing, internal gearing, rack and pinion. So basically in this type of gearing, we can say the mashing of the two gears. Okay, so in the external gearing, this diagram we see that this is the external gearing. In the external gearing, we can say that the gear of two shafts mesh externally with each other. Okay, so the larger of the gear in this diagram, we see that the larger of the gear is called the spur wheel, and the smaller is called the pinion. And one thing is most important for the external gearing is that when the two gear are meshed externally, then the direction of rotation of the both the gears in opposite direction. We can say that when the one gear rotates in clockwise direction, then another gear rotates in anti-clockwise direction. Okay, so it is the main thing for the external gearing. Now we will discuss the internal gearing. In a B diagram, this is that say that this is the internal gearing. Internal gearing means when the gear of two shafts match internally with each other. It is called the internal gearing. In the internal gearing, the larger of the two wheel is called annular gear and the smaller one is called the pinion. And the main important condition of the internal gearing is that same as the external gearing is that with the rotation of both the gears which are in machine are in same direction, which is shown also shown in diagram, or we can say that when the one gear moves rotates in clockwise direction, then another gear is also rotating clockwise direction. So, and last one is the last classification of the two-tooth wheel according to the type of gearing is the rack and pinion. Rack and pinion is the diagram. We see that there are gear of meshes externally and internally with the gears in a straight line. A straight line and is a type of gearing called the rack and pinion. In this case, we see that the straight line gear is shows at the rack and the circular gear is shows at the pinion. Okay, and in this gearing, the rotary motion of the pinion is converted into the linear motion of the rack, or vice versa. We can say that linear motion of the rack is converted into the rotary motion of the pinion. And basically, this gear is used in a steering gear mechanics. Okay, and now we will discuss the last classification of two-tooth wheel, that is the according to the position of the teeth on the gear surface. So basically, there are the three types of gear surface, which is the straight, inclined, and the curve. It is mean the position of the teeth. In a straight gear, the position of the teeth is the straight, or we can say that in this type of gear, the shape of the gear is the straight shape. Or the example of the straight gear is the spur gear. This is the spur gear. The position of the teeth of the spur gear is the always straight. So it is the example of the straight gear. And next is the inclined gear. Inclined gear, when the position of the gear teeth is inclined, or we can say that make an angle to the horizontal. And the example of the inclined gear is the helical gear, which is shown in the diagram. This is the straight teeth, so that is the spur gear, and this is the curved teeth, that is the helical gear. And last one is the curved gear. Curved gear, when the position of the teeth is curved to the gear surface, that is called the curve, and the example is the spiral gear. Now we will discuss the main thing, that is the term used in gears, which is also called as the terminology of the gear. So there are a lot of terminology of the gear which is used in our to identify the gears, and this diagram we see all the terminology of the gear. So firstly, we will discuss the first terminology of the gear, that is called the pitch circle. Or in this diagram, we see that there are the gear in which two teeth of the gear is designed. Okay, so first terminology is the pitch circle. Pitch circle. In this diagram, we see that there is a dotted line which is shown, which is almost the center of the gear is called the pitch circle. And pitch circle is an imaginary circle. That gives by pure rolling action would give the same motion as the actual gear. It is called the pitch circle. Okay. It is an imaginary circle which by pure rolling action would give the same motion as the actual gear. Now next terminology is the pitch circle diameter. Pitch circle diameter is the diameter of the pitch circle, and the size of the gear is usually specified by the pitch circle diameter. It is also known as the pitch diameter. Next is the pitch point. Pitch point is basically a pitch point that in this diagram we can say that pitch point is the common point of contact between the two two pitch circle. Okay, when the two gears are matching, so there one pitch circle of the first gear, there are also a second to the pitch circle of the second gear. In this diagram, we see that one gear and two gear matching. So when the it is when the both the pitch circle is contact at that point is called the pitch point. Okay, next is the pitch surface. Pitch surface is the surface of the rolling disc which the mashing gear have replaced at the pitch circle. Okay, next is the pressure angle or angle of obliquity. It is very important term, and which is the angle between the common normal to two gear teeth at the point of contact and the common tangent at the pitch point. When the two gears are mashing, so there is a common point of contact, and we draw a common normal at the point of contact and the common tangent at the point of contact. And the angle between these is called the pressure angle or angle of obliquity. Okay, and it is usually denoted by phi. The standard pressure angles are 14.5 degree and 20 degree. Okay, now the term is the addendum. Addendum. In this diagram, we see that the addendum is the radial distance of the tooth from the pitch circle to the top of the tooth. Okay, addendum is the radial distance from the pitch circle to the top of the tooth, and the second terminology is dedendum. Dedendum is the radial distance of tooth from the pitch circle to the bottom of the tooth. Okay. Next is the two terms addendum and dedendum. Addendum for the top of the tooth and dedendum for the bottom of the tooth. Okay. Next is the addendum circle and dedendum circle. Addendum circle is the circle drawn from the top of the teeth and is concentrated with the pixel. So we have also discussed that for addendum we use the top of the tooth. So addendum circle, it is the circle drawn from the top of the tooth and it is concentrated with the pitch circle. And the next terminology is the dedendum circle. Dedendum circle, it is the circle drawn through the bottom of the teeth and it is called as the root circle also because it is from the bottom of the tooth, and bottom of the tooth is called the root. And we have also have a formula. We have also have the formula that root circle diameter, we can say dedendum circle diameter equal to the pitch circle diameter into cos phi, where phi is the pressure angle, which have also discussed. Next terminology is the circular pitch. Circular pitch, it is the distance measured on the circumference of the pitch circle from a point on one tooth to the corresponding point on the next tooth. It is usually denoted by PC. This diagram, we see that circular pitch, and circular pitch is nothing. It is the distance measured on the pitch circle, and we take one point on a one teeth and to the corresponding teeth on the second teeth, and the distance between that is called the circular pitch. Or we can say that when we take a first starting point of the first teeth, so when we also take a starting point of a second teeth on the pitch circle, and the distance between them is called the circular pitch, and it is denoted by the PC. And PC, the formula of the circular pitch is the PC equal to the pi d upon t, where capital D is the diameter of the pitch circle and capital T is the number of teeth on the wheel. Okay, a little consideration will show that the two gears will match together correctly if the two wheels have the same circular pitch. Now next is the diametral pitch. Diametral pitch is is the ratio of number of teeth to the pitch circle diameter in millimeter. Okay, it is noted by PD. So now PD is the T upon CD, and T upon D is equal to pi upon BC, because BC equal to pi D upon T. Now next terminology is the module, which is very important, and module is the ratio of the pitch circle diameter in millimeter to the number of teeth, and it is denoted by the small m. So module equal to the m equal to d upon t, where d is the pitch circle diameter, which is in millimeter, and t is the number of teeth. Okay, next is the clearance. Clearance is the radial distance. Clearance. Okay, clearance. It is the radial distance from the top of the tooth to the bottom of the tooth. In a meshing gear, a circle passing through the top of the meshing gear is called the clearance circle. Okay, in this item we see that this is the clearance or working depth circle. Next is the total. Next terminology is the total depth. Total depth is the radial distance between the addendum and dedendum circle of a gear. We can say that it is just a summation of addendum and dedendum. Okay. Now next terminology is the working depth. Working depth is it is the radial distance from the addendum circle to the clearance circle. Okay, it is equal to the sum of addendum of two meshing gears. Okay, next is the tooth thickness. In this diagram, we see that this is the tooth thickness, and tooth thickness is the width of the tooth measured along the pitch circle. Width of the tooth. Next is the tooth space. Tooth space is the width of the space between the two adjacent teeth measured along the pitch circle. Okay, width of the space. Tooth space is the space between the two teeth. Now next terminology is the backlash. It is just the difference between the tooth space and tooth thickness. Okay, and we can say that it is measured along the pitch circle. We can say that backlash should be 0, but in actual practice, the backlash must be allowed to prevent jamming of the teeth due to the tooth errors and thermal expansion. Okay, now next term is the face of the tooth. Face of the tooth, in this diagram we see that the upper portion is called the face and the lower portion is called the flank. So face is the surface of the gear tooth above the pitch surface. Okay, and flank is the flank of the tooth. It is the surface of the tooth below the pitch surface. It is called the flank. Next is the top land. Okay, the above part is called the top land, and the diagram we see that top land is the surface of the top of the teeth. It is called the top land. Next is the face width. Face width is the width of the gear tooth measured parallel to the apex. And next is the profile. Profile is the curve formed by the face and flank of the tooth. Okay, it is called profile because we also have two forms of teeth. First one is the cycloidal tooth and other one is the involute profile. Okay, cycloidal profile is made up of two curves, hypocycloid and epicycloid, and involute profile is made up only of one curve. Okay, last is the split radius, and split radius, it is the radius that connects the root circle to the profile of the tooth. Next terminology is the path of contact. Path of contact is the path traced by the point of contact of two teeth from the beginning to the end of engagement. Okay, it is called the path of contact, and basically next is the length of path of contact. Okay, length of path of contact is the length of common normal cut off by addendum circle of heel and finial. Or basically in the path of contact there are the two paths, that is the from the two paths from the beginning to the end of engagement, and when the two gears are matching, so there also have a one point that is called pitch point when the two pitch circles are matching. So in this diagram, we see that this is the path of contact diagram when the starting of the meshing of teeth to the end of the engagement of teeth. So this is the diagram. We see that PD is the path of contact in which the teeth at the point of C, the meshing of the starting of the meshing and the point of start end of the meshing, and CD is equal to the CP plus CD. Okay. And the last term is the arc of contact. Arc of contact is the path traced by a point on the pitch circle from the beginning to the end of engagement of a given pair of teeth. Okay, there the arc of contact consists of a two parts. First one is the arc of approach, and another one is the arc of repair. Arc of approach is the portion of the path of contact from the beginning to the engagement to the pitch point. Okay, because it is the path traced by the point on which the circle from the beginning to the end of engagement in this point. Okay. So arc of approach is it is a portion of the path of contact from the beginning of the engagement to the pitch point, and arc of recesses is the second part. It is the portion of the path of contact from the pitch point to the end of engagement of a pair of teeth. It is all the terminology used in a gear, and it is used for the identify the gears. Okay. So thank you.